student. Oh, hello. Okay, be the best student you can be, okay? Since you're in the video. Okay, Amari. That's a good example of what not to do. All right. Okay, so today we are going to continue through our unit with the unit circle. Okay. However, we are going to change the units that we're measuring the angle in to radians. So your entire test last unit, you were in degree mode. Do you remember having to switch it over and over again in the calculator? Okay, but today we're going to use radians. Okay, and I want you to think about this is like temperature. You can measure Celsius or Fahrenheit. Distance could be inches or centimeters. Okay, angles can be radians or degrees. Today we're in radian mode. Okay, for radians, 180 degrees is equal to 1 pi. So I want you to label on your circle. Remember, we always start on the positive x-axis. And then remember that positive angles, you go up and around. Negative angles, you go down and around. So if I want to do positive 180 degrees, I would start here and I would twist around to here. This is 1 pi. Now, if it takes 1 pi to go across the top half of the circle, it'll take another pi to go across the bottom half of the circle, which means that all the way around the circle is 2 pi. Okay, so it's 1 pi across the top, another pi across the bottom, which means all the way around 360 degrees is equal to 2. Okay, then if you want to put a little note on this, remember positive angles are up and negative angles you would rotate down. Okay, but remember that overall, you're always starting back on this positive x-axis. Okay, so what our goal is today is to take your circle that is only in degrees, and we are going to also mark it with radians. So we're going to start off with this unit circle right here. Okay, we want 180 degrees to be pi. Okay, which we already know. And now we're going to find some of the other anchor spots on your circle. We're going to convert them into radians. So here's what I mean by that. If this is pi, this is 180 degrees. How much would pi cut in half be? 90, very good. So at 90 degrees, that's perfectly straight up. I want you to label it as pi halves. Okay, and then I'm going to put next to it that if this is 180, half of that would be 90. Now, let's say that I want to take this entire top of this. Remember, this is 1 full pi, and I just cut it in half. What if I were to cut each of those halves in half? How many degrees would I get if I cut 90 in half again? 45 degrees. So I want you to label that right here. Where 45 degrees is, you would call that pi divided by 4. Okay, now if I'm going to sort of think of this as like you're turning a knob. If I go 45 degrees, that's pi fourths. 45 degrees again, that puts me at 90. If I go 45 more degrees this way, that would put me at 3 pi fourths. Okay, and I want you to think about if that makes sense, that if the entire top of this would take 4 twists, I'd go 1, 2, 3, 4, then this would be your third one. So that should a little bit kind of make sense. Okay, the next twist, so this is 1 pi fourth, 2, 3, 4 pi fourths. Does it make sense that 4 pi fourths is the same as 1 full pi? Yeah. Okay, good. So now we're going to keep counting around the bottom half of the circle. So split the bottom half of the circle in half. And then we're going to cut each of those halves in half so that it's 4 pieces instead of only 2. So now let's count the pieces. It's 1, 2, 3, 4 to go around the bottom half of the circle. Okay, so if this is 4 pi-4ths, the next twist would be 5 pi-4ths. Okay, then if I were to twist it again, this would be 6 pi-4ths. The next one would be how many? Follow the pattern. 7 pi-4ths. And now think about, if I twist one more time, that would put me at 8 pi-4ths. But what is 8 divided by 4 the same as? 2. Okay, which we know that one full rotation all the way around the circle, 2 pi is correct. So these are the same, but I would never write it like this. I would write it as 2 pi because the 8 and the 4 can divide. Okay, what other number across the bottom half of the circle could I reduce like this one? 6 over 4. What can those both divide by? 2. So if I divide the 6 by 2, that would go to a 3. 4 divided by 2 would go to a 2. So the bottom of your circle is going to be 3 pi over 2. Okay, here's what we're going to do now. Do not lose your circle, because as we add all this crap to it, okay, you're going to end up having to add it over and over again. So take your circle, and we're going to add these measurements to the circle that you have from last time. Okay, so the circle that I'm talking about is this guy. Okay. All right, let's label our anchor spots first. Okay, 0 degrees and 0 radians are in the exact same spot. So I'm going to put right here, this is my starting position. If I go halfway around the circle, so from here to 180, that's 1 full pi. What was 90 degrees? You remember? It was pi over 2, or pi cut in half. So put right here, this is pi over 2. Then 45 degrees, when I cut the 90 in half, that was pi over 4. Okay, and try to label it right along the line so that as you're looking back on it, you're not confused where your numbers are labeled. Okay, now let's go back to our notes. We had here, here, and here. Can someone tell me what to write along this green line right here? 3 pi over 4, very good. And then remember that along the x-axis, we know that's half the circle, that's 1 full pi. After I go past perfectly 1 full pi, I'm going perfectly dead center here. What should I label that angle? 5 pi-4ths. Now, perfectly straight down, remember it was 6 pi-4ths, but then we fixed it. What did it come out to be once we fixed it? 3 pi over 2, very good. Okay, so 3 pi over 2. And then there was one more left. It went 5 pi-4, 6 pi-4. This would be 7 pi-4. Okay. And then if I go all the way around the circle, remember that all the way around the circle, this would also be 2 pi. Okay, but 0 and 2 pi, you end up in the exact same spot. Okay. All right, so all of the angles highlighted in green, you should have an angle written down. And then we're going to go back to your notes. All right. So let's fill in our little things here. I'll put the circle back up there in a minute if you need it later. We said that pi is 180. So pi over 4, we said was the same as 45 degrees. Okay. Then it says to label negative pi fourths. Well, I want you to think about it in terms of clicks, right? If I rotate 1 click up, that's pi fourths. How would I rotate negative pi fourths? Instead of rotating up, which way would I go? Down. So I would start here and I would do 1 click backwards. What angle is in that spot already? Okay, yes, but we're in radian mode, so it would be 7 pi fourths. Very good. And remember, we would say that that is coterminal with 7 pi fourths. And remember, what that means is that they're in the same spot on the circle. Okay? So we did our halves and our fourths. If you'll come down here to number 2, we're going to remember that we have 1 full pi across the top. But this time, we're going to cut it into thirds. So take the top half of your circle, and I want you to cut it into 3 equal pieces. Okay, so we're going to cut it into 3 pieces. So here's the top half. We'll go here, here. Okay, it doesn't have to be perfect. Just do your best. Now, if the top half of the circle is 180 degrees, and I divide it into 3 equal pieces, how big is the first piece? 180, and I'm going to divide into 3 equal pieces. How many? 60 is correct. So this would be 60, but I'm going to call it pi divided by 3. Okay. Then if I go to the next one, this is 1 pi third. The next one would be 2 pi thirds. And if I do 60 degrees twice, what would the degrees angle be for that? 1. Right? Because I'd go 60 for the first click, then another 60 for the second click. That would put me at pi thirds, 2 pi thirds. Now, the next one would be 3 pi thirds. Does it make sense that that's 1 full pi? 3 thirds, that's 1. Okay, the next one down here, how many would it be? So I'll put 3 pi thirds, but we know that's really just 1 pi. Okay, across the bottom, what would the next click be? So it's 1 pi thirds, 2 pi thirds, 3 pi thirds. What's the next one? 4 pi thirds. Good job. And then the next one would be 5 pi thirds. And then if I go all the way around, that would be 6 thirds, but 6 divided by 3 is 2 full pies. So I'm not going to relabel that. Okay, now that you have that, come over here to your circle. We're going to put those numbers down onto your unit circle. So first thing, I want you to find 60 degrees. Okay, and where the 60 degrees is, we're going to label that as pi thirds. If I double 60, I'd be on 120. That's going to be 2 pi thirds. Okay, then if I go 60 more from 120, where would that put me? So I go 60, 60, 60. That would put me where? 180, right? But 180 is already labeled. So I'm not going to put anything there. Let's go to the next one. That'd be here. 240 and then 300. So this is 1 pi third, 2 pi third, 3 pi thirds. This is 4 pi thirds. And then the next one is 5 pi thirds. Are we all good there? Okay. The last angle, I'm going to see if we can do it without writing on your notes. So if this is a third, a 1/6 would be me cutting that in half again. What is half of 60 degrees? 30. So this angle right here, we're going to label as pi over 6. because it's exactly half of the thirds piece. Okay, so this would be 1 pi 6, 2 pi 6, 3 pi 6. This one is 5 pi 6. Now, another really easy way for you to think about this, and we're going to do this more next time, is remember that the top half of the circle is how much? 1 full pi. So if this is 6, then if I back it up, does it make sense that would only be 5? Okay, so now let's do the same thing going forward. If this is 6 pi 6, I can back up to 5, or I could go forward to what would this be? 7 pi 6. Okay, so 7 pi 6. Okay, now one more question. So I go 6 across the top. I go another 6 across the bottom. What is the whole circle? How many? 6 and then 6 more. 12. Then if I back it up, what does that make this? 11 pi 6. And now your circle is done. Okay. So from here, you should be able to do all of the things that we already covered: sine, cosine, secant, cosecant, tan, cotan, using the circle. Just to remind yourself, if you haven't written it down, cosine is the x value. Go ahead and write it down if it's not on your circle already. Sine, you would pick the y value. Secant is cosine flipped. And CSC is sine flipped. Okay, and then I don't know why I forgot to write tan and cotan on here down, but remember that tan is y over x. And cotan is x over y. Okay, and so we've been covering these rules that you just wrote down over the last several notes. Okay, but we're doing it the same. The only thing that's going to be different is instead of you having a degrees, you're going to have a pi that you have to go to. So let me show you what I mean. Go ahead and turn the page. Okay, and we're going to pick up on the examples with the unit circles, starting with number 1. Okay, so here's what it says. I want cosine pi thirds. Then you are going to go to the x value at pi thirds. So find pi thirds on your circle. Okay, pi thirds is the same as what degree? 60, and then you're going to write down the x. It's a half. Okay? What if I want the sine of pi thirds? Then instead of picking the x value, what am I going to pick? The y value. But at pi thirds, I see my y value is √3/2. So that would be my answer. Okay, let's do 2 more from this section. Let's do the sine of pi halves. Okay, if I want sine, is that the x or the y value? Y value. So can you look at your circle for me, please, and find pi halves on your circle? What degrees is coterminal with pi halves? 90, very good. And at 90 degrees, I want the y value. What is it? 1 is correct. Okay, let's do one more. Last one from this section. So we'll do 7. Find 3 pi halves on your circle. Pi halves is perfectly up. Where is 3 pi halves? Perfectly down. So look at the bottom of your circle. And if it's a cosine question, do I want x or y? Cosine is the x value. What is the x value at the bottom of your circle? 0. Okay, 0 is correct. Got it? Cosine's the x, sine is the y. Let's go on to the next one. Okay, remember, CSC is sine flipped. SEC is cosine flipped. So let's say that I want the CSC for 2 pi thirds. Then I'm going to find the sine of 2 pi thirds. Then I'm going to flip it. So on your circle, I want you to find 2 pi thirds. It should be in the top half. Okay, what angle are we at in degrees? 2 pi thirds is 120. And then CSC is sine. Am I flipping the X or the Y? The Y. What's the original Y value on your circle? Square root 3 over 2. Then my answer is 2 over square root 3. Because remember, I got to flip it for CSC. Now, will Delta Math count this answer correct? No, because remember, no square roots left in the denominator. So I'm just going to root 3. And you should get 2 root 3 over 3. Okay, next one, I want secant 5 pi fourths. Secant is going to be cosine flipped. So you're going to find cosine 5 pi fourths, then flip it. Find 5 pi fourths on your circle. Is it in the top half or the bottom half? Bottom half is correct. Okay, 5 pi fourths is right here. My xy is right here. And cosine, I want the x. So it's negative root 2 over 2. Flip it is 2 over root 2. Can't leave it like that though. So we're going to fix our square roots. My answer is going to be 2 root 2 over 2. Is that correct? What are we forgetting? The negative's got to be there and the 2 is on the outside. If you got the same thing top and bottom, you got to cross those out. So this 2 and this 2 can eliminate each other. Final answer is just negative root. Questions on that? All right, we'll do just one more left. Let's do number 20. Secant 3 pi over 2. Are we flipping the x or the y? Secant, you're flipping the x, which is cosine. So 3 pi over 2, then flip it. 3 pi over 2, find it on your circle. The pi over 2s are either the top or the bottom. Which one is 3 pi over 2? The bottom. What is the x value on the circle? I think the x is 0, right? Yes. Okay, good. Now, if it's 0, I can't flip that by itself. So I would take my 0 and I would say, okay, well, let me put it over 1 so that I have something to flip it with. And then when I flip 0 over 1, now it's going to be 1 over 0. And do we remember what to put for 1 over 0? Undefined. Very good. Okay, so remember, you are not allowed to divide by 0. It's okay to have a 0 on top, but no, you can't have it on the bottom. You would put undefined for that. Okay. And then since we're already on 3 pi halves, I guess we should do 18. What is the y value that I would be flipping for that? Still at 3 pi halves, but now I want the y, not the x. Negative 1. So if I want to flip sine 3 pi halves, and it's a negative 1, then I would put it over 1. And what happens when I flip negative 1 over 1? They do cancel out, but they cancel out to what? Still 1, right? Okay, so when you flip negative 1 over 1, you still get negative 1. Okay, same thing with positive 1. If you flip it, it's going to stay positive 1 because you're flipping the number with its own self. All right, last two. Tangent is y over x. Cotan is x over y. So if I want to find, let's say, the tan of 2 pi thirds, okay, find that angle on your circle for me. 2 pi thirds, and we're doing y over x. So 2 pi thirds is here. My y value is a root 3 over 2, divided by my x is a minus 1/2. And then remember, in last time's notes, we talked about if it's fraction divided by fraction, you're going to keep change flip. So we're going to keep the first fraction, change it to a multiply problem, and then flip the second fraction. So my root 3 over 2 is going to stay the same. That's my keep. we're going to change it to a multiply, and then we're going to flip the -1/2 to be -2/1. From there, what can cross out? The 2's got to go. Now, the negative can stick around unless I have two negatives, right? So then I have -√3, and then technically over 1. But then we know the 1 on the bottom is not necessary, so it's just -√3. Okay. All right, let's do 27. Huh? Okay, look at 27. 3π4. We're doing cotan. Is it y over x or x over y? Cotan is x over y. Very good. Okay, find 3π4 on your circle. Okay, it's right here. My x is a -√2/2. Divided by my y is a +√2/2. And then we know if it's fraction divided by fraction, you're going to keep change flip. Keep the first one the same, change it to a multiply, flip the bottom. So it'd be -√2/2 multiply 2/√2. Now, what we said last time is if you have the same thing top and bottom, they can cross out. What am I going to cross out here? Basically everything, right? You got the 2's, gone. You got the √2's, gone. Negative stays, and you got to keep a 1 on it for a placeholder. That's right. Okay, so -1 would be correct there. Okay. Last two, find 3π12. Okay, and then fill in your numbers. Tan is y over x, cotan is x over y. 3π12 is the bottom of your circle. What will my fraction say for y over x? -1/0. And what's my answer for that? Undefined is correct. Good job, Dory. Okay, and then for my other one, it's 0 over -1. But 0 divided by anything just stays 0. Remember, it's okay to have your 0 on the top. No, you can't have it on the bottom. All right? Okay, the very last thing we have to cover is just positive and negative coterminal angles. So if you'll turn to your back side here. Do you remember how to find a positive coterminal angle in degrees? What do you add or subtract? 360 is correct. So on the back side here, for a positive coterminal angle, you would add 360. For a negative, you would minus it. So if I'm in radian mode and I want to add or subtract one full circle, how many pi's would that be? 2π, very good. So you're going to either add or subtract 2π. Yes? We're almost done, and then I'll send you if that's okay. Thank you. So let's work questions 4 and 5 at the bottom. If I want a positive coterminal angle, I'm going to take the angle they gave me, and I'm going to add 2π to that. Okay, but then the problem is that you can add a fraction with a whole number. Okay, but it's a very easy fix. If I have a 4 on bottom here, and I need a 4 on bottom here, I'm just going to make sure that when I put the 4 on bottom, that I also multiply it by what's on top. So now, instead of me adding a 2π, when I times it by 4, how many am I really going to be adding? An 8. So it would be 3π over 4 plus 8π over 4. And what is 3 plus 8? 11π over 4. Now, for a negative coterminal angle, instead of you adding 2π, what are you going to do? Minus 2π. So I'm going to write almost the same question, but instead of a plus in the middle, I'm going to make it a minus 8π. And as long as the over 4s match, you can just subtract the tops. How did we get what? 8. 8 we times. Yeah, when you put the 4 on bottom, you have to also times it with the top so that they can both have a matching 4. Yep, and then 3 minus 8, what do we get? Negative 5 pi over 4. All right, last example like that. Write down 2 pi thirds. Okay, we're going to add 2 pi to that for a positive coterminal angle. So I have 2 pi thirds, and I want to add 2 pi. But my 2 pi doesn't have a bottom, and I need it to have what number on bottom to match? A 3. If this guy has a 3, then this guy needs a 3 on bottom as well. So when I place that 3 on the bottom, I'm going to also multiply it on top. Which means what's going to happen to my 2 pi? Now it's a what? 6 pi. So I have 2 pi thirds plus 6 pi thirds. And now that the thirds part of that fraction is called a common denominator, if you remember that. Okay, the bottom number is the same. You can add the tops together. What is 2 pi plus 6 pi? 8 pi thirds. And then the only difference from a positive to a negative is instead of adding for a positive, what would I do for a negative? Your plus would turn to a minus. So it'd be 2 pi thirds minus 6 pi thirds. And then 2 minus 6, what we get for that? Negative 4 pi thirds. Okay. Questions on that? Okay. That should be enough for you to do your homework. If you have any questions, let me know and I'll bring scratch paper around. Yeah, go ahead.
I said Casey.
Can I have you move up here though since you're testing? All right, we need scratch papers. The word stuff out. What's that? Oh, I gave you 2. Paper? I owe you paper? Okay, will you sit up there behind you?
My friend,
Did you ask? Oh yeah, I'll take it. You just put it on my keyboard right there. Thank you, Jasmine. Y'all, if you have your test review and you forgot to turn it in, I'll take it. No, that's not a charger. Or did somebody take it?
Oh, I have to.
Oh, is it charging your stuff?
Yeah, you can use it. It's like plug them back.
It's the one with the green sticker on it. Okay, do y'all have your warm-ups?
What have your one?
I think I thought y'all were that. I didn't pull yours. Yes? Okay. Keep on. What do you have, 6? Do you think they'd let you come take it today? Or maybe a class tomorrow? 8 today? That's fine.
Are you already started grading it?
I did, but just keep working on it and I'll just regrade it.
Wait, I thought you said the picture didn't matter.
It doesn't. You didn't lose points for it.
You're
I thought I drew that on it while we were taking that. Oh, yeah. But you didn't lose points for it.
I don't think you started grading it. I just
Okay.
use our notes. Like, yeah.
Okay. Okay, Case and I did start grading yours, but just pretend. On today.
Oh, you didn't. Oh.
No, I didn't. Oh, you don't need this? Oh.
Oh, wait.
It would be the X value and then you would flip the number. So like, where is 3 5 fourths? Your X is a negative √2/2. So when you flip it, this is frozen, it would be negative √2. So it was this one, right? So it would go to -2/√2, but then you can't type it in like that because of the squared on the bottom. So you do another √2. And then what would you have? 2 √2/2, and then you would cross those two. So it should just be negative √2.